Welcome to Dreamy Facts. As the day gently recedes, we invite you to settle into a space of calm contemplation. Tonight, we embark on a journey through the intricate tapestry of our planet, exploring approximately 100 fascinating geography facts that reveal the Earth's profound beauty, its ancient processes, and the remarkable diversity of its landscapes. There is no pressure to remember or retain these details. Instead, let them unfold naturally, inviting your mind to settle into a state of peaceful curiosity. This exploration is designed to be a soothing experience, a gentle current of knowledge flowing without demanding effort or attention. We will observe the intricate dance of tectonic plates, the subtle adaptations of landforms shaped by millennia, and the quiet wisdom embedded in the very ground beneath our feet. Each fact is a small window into the vast and interconnected tapestry of geography, presented in a calm and meditative tone, allowing your thoughts to drift and find stillness. We will traverse immense oceans, scale towering peaks, delve into the deepest trenches, and marvel at the subtle shifts that define our world. Allow the gentle rhythm of these discoveries to guide you towards a state of relaxation, inviting a sense of wonder and peace as you prepare for rest. If you're finding peace in this journey, a like and subscribe helps us continue creating these restful explorations, and we're always curious. Share in the comments what city and time zone you're watching from. There's something special about knowing this experience is reaching people all over the world as they prepare for rest. Tonight, we begin our exploration by considering the foundational aspects of our planet, observing the grand blueprint of Earth itself and the remarkable extremes that define its surface. We will contemplate its shape, its highest and lowest points, and the vastness of its oceans, inviting a sense of scale and wonder. Our journey begins with the very essence of our home, Earth. Scientists describe our planet not as a perfect sphere, but as an oblate spheroid, a shape that is slightly flattened at the poles and bulges at the equator. This subtle distortion is a direct result of Earth's rotation, which creates a centrifugal force, gently pushing matter outwards at the equator. Research indicates that the equatorial diameter of Earth is approximately 7,926 miles, 12,156 kilometers, while the polar diameter is slightly less, around 7,900 miles, 12,914 kilometers. This slight difference, though imperceptible to the eye, is a fundamental characteristic influencing various geological and atmospheric processes. The Earth's rotation also contributes to the Coriolis effect, a force that deflects moving objects, including ocean currents and wind patterns, to the right in the northern hemisphere and to the left in the southern hemisphere, a key factor in global weather systems. Current understanding suggests that without this rotation, our planet's climate and ocean circulation would be vastly different, creating an entirely alien world. From its overall shape, we turn our gaze to the most dramatic vertical measures on Earth, its highest and lowest points. Mount Everest, nestled in the Himalayas, stands as the highest point above sea level, reaching an elevation of approximately 29,031.7 feet, 8,048.86 meters. This majestic peak is a result of the ongoing collision between the Indian and Eurasian tectonic plates, a process that continues to uplift the mountain range by a small margin each year. Geological studies show that the rocks composing Everest were once at the bottom of an ancient ocean, a testament to the immense forces that shape our planet over millions of years. Conversely, The lowest point on Earth's land surface not covered by ocean is the shore of the Dead Sea bordering Jordan, Israel and Palestine. Its surface lies approximately 1,412 feet, 430.5 meters below sea level, a unique geographical depression formed by the Dead Sea Transform Fault System, a rift valley that is slowly pulling the land apart. This extraordinary saline lake is fed primarily by the Jordan River, and its high salt content prevents the survival of most aquatic life, creating a stark, beautiful landscape. Beneath the waves, the Earth reveals even greater depths, particularly within its vast oceans. The deepest known point in Earth's oceans, and indeed on the planet, is the Challenger Deep, located in the Mariana Trench in the western Pacific Ocean. Measurements indicate its depth to be around 35,176 feet, 10,935 meters. A chasm so profound that if Mount Everest were placed within it, its summit would still be over a mile beneath the surface. This trench is formed by the subduction of the Pacific Plate beneath the Mariana Plate, a process where one tectonic plate slides beneath another, creating an immense elongated depression. Research shows that despite the extreme pressure and complete absence of sunlight, a surprising array of life forms, including unique microorganisms and specialized invertebrates, thrive in these abyssal conditions. The immense pressure at the Challenger Deep is over 1,000 times that at sea level, presenting an environment that pushes the boundaries of biological adaptation. Shifting our focus to the expansive dry realms, we observe the planet's largest deserts. The largest hot desert in the world is the Sahara, spanning approximately 3.6 million square miles, 9.2 million square kilometers, across much of North Africa. This vast arid region is characterized by extreme temperatures, sparse vegetation, and immense sand dunes that can reach heights of over 600 feet. The Sahara's formation is attributed to its location beneath a persistent high-pressure system, which inhibits cloud formation and rainfall. Historical records and paleoclimatic studies suggest that the Sahara has undergone significant shifts between wet and dry periods over geological timescales, with evidence of ancient rivers and lakes. However, the largest desert overall, encompassing both hot and cold classifications, is the Antarctic Polar Desert, covering nearly 5.5 million square miles, 14 million square kilometers. It is a polar desert because its extremely cold temperatures lead to very little precipitation, and any moisture that falls remains locked in ice. The dry valleys of Antarctica are considered some of the driest places on Earth, with virtually no snow or ice cover, due to strong katabatic winds that evaporate any moisture. The lifeblood of continents often flows through their longest rivers, shaping landscapes and supporting ecosystems. The Nile River, historically considered the longest river in the world, stretches approximately 4,132 miles, 6,650 kilometers, through northeastern Africa, flowing into the Mediterranean Sea. Its immense basin supports a diverse range of cultures and wildlife, with its annual flooding historically depositing fertile silt along its banks, crucial for agriculture. However, recent scientific consensus, based on more precise satellite mapping and hydrological studies, suggests that the Amazon River in South America might be slightly longer, with estimates placing its length at around 4,145 miles, 7,000 kilometers. The Amazon carries an astonishing volume of water, discharging more than any other river into the Atlantic Ocean, accounting for about 20% of the global riverine discharge. Its vast rainforest basin is a biodiversity hotspot, home to an unparalleled array of plant and animal species, and plays a critical role in global climate regulation. Turning our attention to freshwater bodies, we find the largest lakes. The Caspian Sea, despite its name, is technically the world's largest enclosed inland body of water by area, covering approximately 143,200 square miles, 371,000 square kilometers. It is classified as a lake because it is entirely landlocked, though its waters are brackish, a mix of fresh and saline, due to its ancient connection to the ocean and subsequent isolation. Its vast size and unique ecosystem supports several endemic species, including the Caspian seal. In terms of freshwater volume, Lake Baikal in Siberia, Russia, holds the distinction of being the largest and deepest freshwater lake. It contains about 20% of the world's unfrozen surface freshwater, with a maximum depth of approximately 5,387 feet, 1,642 meters. Geological studies indicate that Baikal is an ancient rift lake, formed by tectonic activity, and its age is estimated to be around 25-30 million years, making it one of the oldest lakes on Earth. Its pristine waters and unique biodiversity, including thousands of endemic species, make it a natural wonder. From vastness, we observe the smaller scales of our world, such as the smallest continent and countries. Australia is recognised as the smallest continent, often referred to as an island continent, covering an area of approximately 3 million square miles, 7.7 million square kilometres. Geologically, it is the lowest, flattest and oldest continental landmass, with a unique array of endemic flora and fauna that evolved in relative isolation. Its ancient geological history is evident in its vast deserts, ancient mountain ranges, and unique rock formations. The smallest sovereign state in the world by both area and population is Vatican City, an independent city-state located within Rome, Italy. Its area is just 110 acres, 0.44 square kilometers, and it serves as the spiritual and administrative center of the Roman Catholic Church. This tiny nation exemplifies how political and cultural significance can exist independently of vast geographical size. Some of the most intriguing geographical features are the Earth's most remote islands, isolated specks of land in vast oceans. Easter Island, or Rapa Nui, in the southeastern Pacific Ocean, is one of the most remote inhabited islands, lying approximately 2,075 miles, 3,500 kilometers, west of Chile. It is renowned for its monumental statues, the moai, carved by its ancient Polynesian inhabitants, offering a glimpse into a complex civilization that thrived in extreme isolation. Another example is Bouvet Island, an uninhabited volcanic island in the South Atlantic Ocean, claimed by Norway. It is often cited as the most remote island on Earth, located about 1,060 miles, 1,700 kilometers, north of the Princess Astrid coast of Antarctica. Its harsh, ice-covered landscape and extreme weather conditions make it largely inaccessible, a testament to the planet's untouched wildernesses. The Earth's dynamic nature is dramatically demonstrated by volcanic activity and the Ring of Fire. The Pacific Ring of Fire is a major area in the basin of the Pacific Ocean, where a large number of earthquakes and volcanic eruptions occur. It is a horseshoe-shaped belt that stretches for approximately 25,000 miles, 40,000 kilometers, and is home to over 75% of the world's active and dormant volcanoes, This intense geological activity is a direct consequence of plate tectonics, specifically the movement and collision of several major tectonic plates, including the Pacific Plate, which is subducting under other plates. Scientists have observed that the subduction zones along the Ring of Fire create deep ocean trenches, such as the Mariana Trench, and fuel the formation of magma, leading to explosive volcanic eruptions and frequent seismic activity. The continuous interplay of these forces constantly reshapes the Earth's crust, creating new land and altering coastlines over geological timescales. These foundational facts reveal the immense scale and dynamic processes that define our planet. From its slightly flattened shape to the profound depths of its oceans and the fiery activity of its volcanic zones, Earth is a world of constant motion and breathtaking extremes. We observe how these fundamental geographical characteristics, often hidden from plain sight, underpin the very existence of the diverse landscapes and ecosystems that will continue to unfold in our journey. As the fiery pulse of the Pacific Ring of Fire gently recedes from our contemplative awareness, we now turn our gaze not to the terrestrial tumult, but to the serene, enveloping presence that defines our planet, water. Indeed, Earth, often called the Yamda, the quote one, is fundamentally a world of water, a liquid realm that shapes its surface, moderates its climate, and cradles an astonishing diversity of life. We invite you to drift with us now upon the vast interconnected expanse of the global ocean, and then ascend into the ethereal layers of its atmospheric veil, observing the delicate yet powerful forces that perpetually sculpt our world. Imagine, if you will, the sheer immensity. Over 70% of Earth's surface is submerged beneath this aqueous embrace, a single, continuous body of water that we segment into oceans and seas merely for the convenience of cartography. This vast liquid tapestry is not static. It is a dynamic, pulsating system, driven by forces both celestial and terrestrial. Consider the profound phenomenon of ocean currents, those colossal, invisible rivers flowing within the larger ocean. The thermohaline circulation, often referred to as the global conveyor belt, is a majestic example. This deep ocean current system, propelled by differences in temperature, thermo, and salinity, haline, moves enormous volumes of water across the planet's abyssal plains, a journey that can span millennia. Cold, dense, saline water sinks in the polar regions, then slowly creeps along the ocean floor, eventually rising in warmer zones, distributing heat and nutrients vital for marine ecosystems across the globe. It is a slow, deliberate dance of planetary respiration, influencing climates from the tropics to the poles. A more familiar manifestation of this oceanic dynamism is the Gulf Stream, a powerful, warm, and swift Atlantic Ocean current that originates in the Gulf of Mexico and extends to the North Atlantic. Its influence is nothing short of transformative. Transporting warm tropical waters northward, it significantly moderates the climate of Western Europe, rendering its latitudes far milder than comparable regions elsewhere on Earth, such as Newfoundland in Canada, which lies at a similar parallel but experiences dramatically colder conditions. Without the Gulf Stream's benevolent thermal embrace, much of Europe would be locked in a far more frigid state, a stark testament to the profound climatic power of these oceanic arteries. And then there are the tides, the rhythmic rise and fall of sea levels, a daily ballet choreographed by the gravitational pull of celestial bodies. Predominantly, it is the Moon's gravitational force that exerts the most significant influence, its proximity creating a bulge of water on both the side of Earth facing it and, counterintuitively, on the opposite side as well, due to inertial forces. The Sun, though far more massive, is much more distant, contributing a lesser, yet still discernible, gravitational tug. This intricate celestial interaction results in the twice-daily ebb and flow that has shaped coastal landscapes and human maritime endeavours for millennia, a subtle reminder of our planet's cosmic connections. Within these vast watery expanses reside some of Earth's most breathtakingly diverse ecosystems. The coral reefs, often dubbed the Asanyan *3, are prime examples. These vibrant underwater cities, built by tiny polyps over millennia, harbour an astonishing quarter of all known marine species, despite occupying less than 1% of the ocean floor. The Great Barrier Reef. Off the coast of Australia, stretching over 1,400 miles, is the largest living structure on Earth, a testament to biological architecture on a truly grand scale. Its intricate labyrinths of colour and life provide crucial habitats, nurseries, and feeding grounds, underscoring the delicate interdependence of marine life. Yet these fragile ecosystems are increasingly under threat, their quiet resilience challenged by a changing climate and human impact, urging us to contemplate our stewardship of these irreplaceable natural wonders. As our gentle journey continues, we shift our focus from the liquid expanse to its solidified, majestic forms, the planet's vast reservoirs of ice. These frozen realms represent not only immense stores of fresh water, but also powerful geological agents and crucial indicators of global climate. The Antarctic ice sheet. An overwhelming presence covering nearly 98% of the continent, is the largest single mass of ice on Earth, averaging over a mile in thickness, and in some places reaching nearly 3 miles. It contains approximately 90% of the world's freshwater ice, and about 70% of the planet's total freshwater. Should this immense volume melt entirely, global sea levels would rise by approximately 200 feet, a staggering potential transformation of our coastlines. Its sheer scale and profound significance in regulating Earth's climate are almost beyond human comprehension. A silent, colossal sentinel at the bottom of the world. Similarly, the Greenland ice sheet, though smaller than its Antarctic counterpart, is the second largest body of ice on the planet, holding enough water to raise global sea levels by about 24 feet if completely melted. These vast glaciated expanses are not merely static frozen landscapes, they are dynamic systems, slowly flowing under their own immense weight, carving landscapes and influencing oceanic circulation. Evidence of their ancient power can be seen in the majestic fjords that grace the coastlines of Norway, Chile, New Zealand, and other glaciated regions. These long, narrow, deep inlets of the sea, often flanked by towering cliffs, are not river valleys but rather U-shaped valleys, carved by the relentless erosive power of glaciers that once extended to the coast. As the glaciers retreated, the sea flooded these magnificent troughs, leaving behind breathtaking landscapes that whisper tales of geological epochs past. Beneath the surface of much of the Arctic and subarctic regions lies another frozen secret: permafrost. This is ground, soil, rock or sediment that remains completely frozen, 0°, 30 certuda, or colder, for at least 2 consecutive years. Covering approximately 15% of the Northern Hemisphere's land area, permafrost is not merely frozen Earth, it is a vast, ancient repository of organic carbon locked away for millennia. As global temperatures rise, this permafrost is thawing, releasing potent greenhouse gases such as carbon dioxide and methane into the atmosphere, creating a complex feedback loop that further accelerates warming. It is a quiet, slow-motion unveiling of Earth's past, with profound implications for its future, a poignant example of the interconnectedness of our planet's systems. Having traversed the liquid and solid states of Earth's dominant element, we now invite you to ascend gently into the invisible realm that envelops our world, the Earth's atmosphere. This gaseous envelope, though imperceptible to our touch, is as vital and dynamic as the oceans, a protective shield and a complex engine of weather and climate. We find ourselves in the troposphere, the lowest layer, extending up to about 12 miles 20 kilometers from the surface. This is where all terrestrial weather occurs, where the air we breathe circulates, and where the intricate dance of clouds, winds, and precipitation unfolds. It is our immediate atmospheric home, teeming with the energy that drives our daily meteorological experiences. Above the troposphere lies the stratosphere, extending to about 31 miles, 50 kilometers altitude. Within this layer resides the crucial ozone layer, a thin yet immensely significant shield of ozone molecules, O3. This layer absorbs most of the sun's harmful ultraviolet, UV, radiation, protecting life on Earth from its damaging effects. Without this delicate atmospheric filter, terrestrial life as we know it would be impossible, a testament to the serendipitous conditions that allowed complex life to flourish on our planet. The atmosphere, therefore, is not merely air. It is a sophisticated, multi-layered defense system. Within this atmospheric envelope, vast energies are constantly at play, driving the majestic patterns of global wind circulation. These are not random gusts, but organized planetary-scale movements of air, driven by differential heating from the sun. The Hadley cells, for instance, are massive atmospheric convection currents that dominate tropical and subtropical regions. Warm, moist air rises at the equator, creating a band of low pressure and abundant rainfall, then flows poleward, cooling and sinking at around 30 degrees latitude, resulting in high pressure and arid conditions, hence the location of many of the world's great deserts. Further poleward, the feral cells and polar cells complete this elegant system, transporting heat from the equator towards the poles, an intricate mechanism of global thermal regulation. The jet streams. Those narrow bands of strong, fast-moving air found at high altitudes are another powerful component, influencing weather systems across continents as they meander through the upper troposphere and lower stratosphere. One of the most dramatic manifestations of these global wind patterns is the phenomenon of monsoons. These are not merely heavy rains, but rather seasonal reversals of wind direction, typically accompanied by significant changes in precipitation. The Asian monsoon, for example, is a colossal system driven by the differential heating of land and sea. In summer, the vast Asian landmass heats up faster than the surrounding oceans, creating a low-pressure system that draws moist air from the Indian Ocean inland, unleashing torrential, life-giving rains crucial for agriculture and ecosystems. In winter, the land cools, generating high pressure that pushes dry air seaward. This biannual atmospheric breath profoundly shapes the lives and landscapes of billions, a powerful illustration of the interplay between land, sea, and air. And as night descends, painting the canvas of the sky with the deepening hues of twilight, we are sometimes gifted with one of Earth's most ethereal atmospheric spectacles, the auroras. These shimmering curtains of light, known as the aurora borealis in the northern hemisphere and aurora australis in the southern, are a mesmerizing display of cosmic interaction. They occur when energetic particles from solar winds, ejected from the sun, collide with gases in Earth's upper atmosphere. Guided by our planet's magnetic field towards the poles, these collisions excite atmospheric atoms, causing them to emit light in vibrant greens, pinks, and purples. It is a stunning visual reminder of Earth's protective magnetic shield and its dynamic interaction with the solar system, a celestial ballet performed at the edges of our world. Having journeyed through the dynamic embrace of water, both liquid and frozen, and soared through the intricate layers of our atmosphere, we conclude this segment of our exploration with a brief contemplation of how these forces, combined with the Earth's own geological pulse, sculpt truly unique and monumental terrestrial features. Consider the Grand Canyon, a chasm of unparalleled scale located in Arizona, USA. This immense geological incision, over 277 miles long, up to 18 miles wide and a mile deep, is primarily the work of the Colorado River, which has tirelessly carved its way through layers of rock over millions of years. It is a living geological textbook, revealing nearly 2 billion years of Earth's history in its exposed rock strata, a testament to the relentless, patient power of fluvial erosion and tectonic uplift. Its silent, profound beauty invites a deep sense of humility and wonder, a window into geological time. Equally compelling are the subterranean wonders of karst topography. This distinctive type of landscape is formed by the dissolution of soluble rocks, primarily limestone, dolomite, or gypsum, by groundwater. Over vast stretches of time, this slow chemical erosion creates a labyrinthine world of caves, sinkholes, disappearing rivers, and springs. Within these hidden grottos, the slow drip of mineral-laden water forms spectacular stalactites, hanging from the ceiling, and stalagmites, rising from the floor, cathedral-like formations that can take millennia to grow by mere inches. Regions like the Yucatan Peninsula, parts of Slovenia, and the Guilin region of China showcase the dramatic surface expressions of karst, with their conical hills and verdant depressions hinting at the intricate underground networks below. These landscapes are a reminder that Earth's most profound beauty often lies both above and beneath our immediate perception. Finally, let us briefly marvel at the otherworldly landscapes of salt flats. Vast plains of salt-crusted earth, often shimmering under intense sun. The Salar de Uyuni, in Bolivia, the world's largest salt flat, spans over 4,000 square miles and is a surreal expanse of dazzling white. Formed from the evaporation of ancient lakes, it is not only a natural wonder, but also a significant source of lithium, a vital mineral for modern technology. These flats are stark, beautiful reminders of hydrological cycles and geological processes, where water, in its final act of evaporation, leaves behind crystalline legacies. As we gently bring this segment of our journey to a close, allowing these images of oceanic currents, frozen giants, atmospheric ballets, and sculpted landscapes to settle within your mind. We hope you find a renewed sense of connection to the dynamic living planet beneath your feet. Remember, there is no pressure to retain every detail, only to absorb the wonder, to allow the quiet wisdom embedded in these facts to deepen your contemplation. If you are enjoying this tranquil exploration, we invite you to acknowledge it with a gentle like, or perhaps consider subscribing, allowing us to continue these shared moments of serene discovery. Tonight, we have drifted through the aqueous and gaseous envelopes of Earth, preparing for the next chapter of our journey, where we will delve even deeper into the intricate tapestry of our planet's remarkable diversity. Let these thoughts linger softly as you prepare for a peaceful repose, knowing that the Earth continues its grand, ancient processes even as you rest. As we gently recede from the sculpted marvels of the Grand Canyon and the intricate lacework of karst topography, our journey now calls us deeper, inviting us to contemplate the very forces that ceaselessly reshape our planetary canvas. Tonight, we shall venture beneath the surface, exploring the profound geological processes that serve as the grand architects of Earth's myriad features, a testament to its dynamic and ever-evolving nature. Allow your mind to drift, unburdened by the need for memorization, as we observe the quiet wisdom embedded within the planet's ancient strata. We begin our subterranean exploration with the majestic slow-motion ballet of plate tectonics, the fundamental framework that dictates Earth's surface dynamics. Imagine our planet's rigid outer shell, the lithosphere, not as a single, unbroken sphere, but as a colossal jigsaw puzzle composed of several immense, irregularly shaped pieces. These are the tectonic plates. Geological studies reveal that these plates, both oceanic and continental, are in perpetual, albeit imperceptibly slow, motion, gliding atop the semi-fluid asthenosphere. This ceaseless movement, driven by convection currents within the Earth's molten mantle, is the primary engine behind virtually all large-scale geological phenomena. Consider for a moment the divergent plate boundaries, where plates gracefully pull apart. Here, molten rock, or magma, ascends from the mantle, creating new crustal material. A prime example of this constructive process is the Mid-Atlantic Ridge, an immense submarine mountain range that snakes for over 10,000 miles across the floor of the Atlantic Ocean, a veritable seam where the North American and Eurasian plates, along with the South American and African plates, are steadily separating at an average rate of about 2.5 centimeters per year. This constant upwelling forms rift valleys and submarine volcanoes, adding fresh layers to our planet's foundation. On land, divergent boundaries manifest as dramatic rift valleys, such as the East African Rift Valley, a colossal scar stretching thousands of kilometers, where the African continent is slowly, inexorably tearing itself asunder, a process that may, over unimaginable eons, lead to the birth of a new ocean basin. Conversely, we observe the profound power of convergent plate boundaries, where plates majestically collide. These interactions are incredibly varied and give rise to some of Earth's most spectacular and awe-inspiring features. When an oceanic plate, denser and thinner, encounters a continental plate, it often plunges beneath it in a process known as subduction. This descent into the mantle generates deep ocean trenches, such as the Mariana Trench, and fuels the formation of volcanic mountain ranges along the continental edge, like the majestic Andes Mountains of South America. When two oceanic plates converge, one subducts beneath the other, giving rise to chains of volcanic islands, or island arcs, epitomized by the Japanese archipelago, a testament to the fiery creativity of the deep earth. Perhaps the most dramatic manifestation of convergence occurs when two continental plates, both relatively buoyant, collide head-on. Neither plate readily subducts, resulting in immense compressional forces that buckle, fold, and thrust the crust upwards, giving birth to the world's most colossal mountain ranges. The Himalayas, home to Mount Everest, stand as a towering monument to such an event, a testament to the ongoing collision between the Indian and Eurasian plates, which continues to elevate these peaks by several millimeters each year. Then there are the transform plate boundaries, where plates neither converge nor diverge, but rather slide horizontally past one another. While seemingly less dramatic on the surface, these lateral movements are far from quiescent. The immense friction generated along these boundaries builds colossal stresses within the crust, which are periodically released as sudden, violent tremors, giving rise to earthquakes. The infamous San Andreas Fault in California, where the Pacific Plate grinds past the North American Plate, is a quintessential example of a transform boundary, a geological scar that silently, yet powerfully, reminds us of the planet's restless energy. This intricate dance of tectonic plates is intimately linked with the phenomenon of volcanism. Volcanoes are not merely isolated mountains that erupt. They are direct conduits to the Earth's molten interior, serving as vents for the planet's internal heat and pressure. We distinguish between different types: the majestic cone-shaped stratovolcanoes, like Japan's iconic Mount Fuji, known for their explosive eruptions of viscous lava and ash, typically found along subduction zones. In contrast, shield volcanoes, such as Hawaii's colossal Mauna Loa, are characterized by their broad, gently sloping profiles, formed by effusive eruptions of fluid basaltic lava that flows freely, building up vast, shield-like structures over countless millennia. These volcanic eruptions, whether explosive or effusive, play a crucial role in creating new land, as evidenced by the continuous growth of the Hawaiian Islands, a veritable archipelago born from a stationary hot spot beneath the Pacific Plate. Beyond the immediate spectacle of eruptions, volcanic activity also manifests in more subtle, yet equally captivating forms, such as the bubbling mud pots, steaming fumaroles, and spectacular geysers. Of Yellowstone National Park, all powered by the subterranean heat of the Earth's magma chambers. The sudden release of energy along fault lines, often associated with plate boundaries, is the genesis of earthquakes. These powerful seismic events occur when accumulated stress in the Earth's crust exceeds the strength of the rocks, causing them to fracture and slip. The energy released propagates through the Earth as seismic waves, which we measure using seismographs to determine the earthquake's magnitude on scales like the moment magnitude scale. While the tremors themselves can be devastating, undersea earthquakes, particularly those occurring in subduction zones, can displace massive volumes of ocean water, generating colossal ocean waves known as tsunamis. These powerful waves, capable of traveling across entire ocean basins at immense speeds, can unleash unimaginable destruction upon coastal communities, serving as a stark reminder of the ocean's profound power when stirred by geological forces. As we ponder these dynamic forces, we also consider the Earth's enduring rock cycle, a continuous process of transformation that recycles the planet's crustal material over vast geological timescales. We categorize rocks into three fundamental types: igneous rocks, born from the cooling and solidification of molten magma or lava, forming the very bedrock of continents and ocean floors; sedimentary rocks, formed from the accumulation and compaction of sediments derived from the weathering and erosion of pre-existing rocks, often preserving ancient fossils within their layered structures, telling stories of bygone eras; and metamorphic rocks, which arise when existing igneous, sedimentary, or other metamorphic rocks are subjected to intense heat, pressure, or chemical alteration deep within the Earth's crust, resulting in profound changes to their mineralogy and texture. This ceaseless cycle, from magma to igneous, to sediment, to sedimentary, to metamorphic, and back again, is a testament to the Earth's continuous internal workings, a grand, slow dance of creation and destruction. These processes unfold over periods of time so immense they challenge human comprehension. Geological time. The Earth itself is approximately 4.54 billion years old, a number that renders our human existence a mere fleeting instant. Understanding this vast temporal canvas allows us to appreciate that the towering mountains, deep canyons, and vast ocean basins we observe today are but transient snapshots in an ongoing billion-year saga of formation and transformation. Yet the Earth's surface is not solely shaped by its fiery interior. Erosion and weathering. The patient sculptors of the external world tirelessly work to break down and transport rock material. Weathering. The physical and chemical disintegration of rocks is the preliminary step turning solid rock into sediment. This broken down material is then transported by erosion. Primarily through the relentless action of water in rivers and glaciers, the persistent force of wind, and even the subtle yet powerful influence of biological agents. Over eons, these external forces carve magnificent landscapes. The towering mesas and isolated buttes of Monument Valley, sculpted by differential erosion of softer and harder rock layers. The intricate network of sea arches and stacks along coastlines, testimony to the ocean's ceaseless battering, and the vast undulating sand dunes of deserts, shaped by the tireless whisper of the wind. Finally, we consider the thin living skin of our planet, soil. Far from inert dirt, soil is a complex dynamic medium, a vital interface between the lithosphere, atmosphere, hydrosphere, and biosphere. It is the product of millennia of weathering, organic decomposition, and biological activity, influenced by a myriad of factors including climate, parent rock material, topography, the activity of countless organisms, and the sheer passage of time. Soil is the foundation of terrestrial life, sustaining forests, grasslands, and agricultural lands, serving as a critical reservoir for water and nutrients, and playing an indispensable role in the global carbon cycle. The distribution of different soil types across the globe profoundly influences biogeography. The study of the distribution of species and ecosystems in geographical space and through geological time. It helps us understand why certain biomes, vast ecological zones like tropical rainforests or boreal forests, occur where they do, and why certain species are endemic to specific regions, profoundly shaped by the unique interplay of geology, climate, and biological evolution. As the gentle currents of these profound facts wash over you, we hope a sense of tranquil wonder settles within your consciousness. Tonight, we have traversed the fiery heart of our planet, witnessed the slow, majestic dance of continents, and observed the patient artistry of erosion, all contributing to the intricate, ever-changing tapestry that is Earth. May these revelations about our dynamic world deepen your calm contemplation, preparing you for a restful slumber. We invite you to join us again as we continue our journey through these 100 incredibly interesting geography facts, uncovering more of Earth's quiet wisdom. Sweet dreams, and may your mind find peace in the grand blueprint of our remarkable home. As the grand, patient forces of geology continue their ceaseless work, sculpting the very foundations of our world, we now turn our gaze from the deep Earth's restless heart to its vibrant living mantle. We have journeyed through the immense scale of our planet, observed the profound energy of its tectonic dance, and contemplated the slow, deliberate artistry of erosion and deposition. Now, dear traveller, we invite you to drift with us into the intricate tapestry woven by these geological processes, combined with the celestial ballet of solar radiation and the dynamic breath of the atmosphere. This is the realm where life, in its myriad forms, has taken root, adapted, and flourished, painting the Earth with an astonishing palette of biomes and ecosystems. Tonight, we shall explore how the interplay of climate, topography, and hydrological cycles orchestrates the distribution of life, creating distinct geographical zones, each a marvel of adaptation and interconnectedness. Allow your mind to gently unfurl as we traverse these living landscapes, observing the quiet wisdom embedded within their structures and appreciating the profound ingenuity of nature's design. There is no need to retain every detail. Simply let the images and insights wash over you, preparing your spirit for tranquil contemplation. Our journey begins in the verdant embrace of the tropical rainforests, regions where life attains an unparalleled exuberance, a testament to abundant warmth and ceaseless precipitation. Here, near the equator, solar energy is intense and consistent, fueling a perpetual cycle of growth. Consider the Amazon rainforest, spanning 9 South American nations, which represents over half of the planet's remaining rainforests and harbours an estimated 10% of the world's known species. Within its dense, multi-layered canopy, an intricate vertical stratification of life unfolds. The emergent layer, with trees reaching heights of over 200 feet, pierces the sky, while the subcanopy and understory layers teem with a bewildering array of flora and fauna, each species occupying its specialized niche. The sheer biomass here is staggering, with some areas receiving over 80 inches of rainfall annually, a deluge that sustains an extraordinary biodiversity crucial for global oxygen production and carbon sequestration. The very air pulses with life, thick with humidity and the symphony of countless organisms. From this luxuriant abundance we journey to the stark contrasts of the deserts. Geographical expressions of extreme aridity, these vast expanses covering roughly 1/3 of Earth's land surface are defined by minimal precipitation, often receiving less than 10 inches per year. Yet, within their challenging environments, life persists with remarkable resilience. The Atacama Desert in Chile, for instance, is considered the driest non-polar desert on Earth, with some areas experiencing virtually no recorded rainfall for centuries, a consequence of its rain-shadow location between the Andes Mountains and the cold Humboldt Current. Despite this, specialized cacti, succulents, and ephemeral wildflowers burst forth during rare precipitation events, while unique fauna, adapted to conserve every drop of moisture, navigate its austere beauty. In contrast, the Gobi Desert in Central Asia presents a cold desert environment, characterized by extreme temperature fluctuations, with scorching summers and frigid winters, its landscape sculpted by powerful winds that sweep across vast plateaus. The diversity of desert types, from subtropical to coastal to cold, underscores the manifold ways in which a lack of water can shape an entire ecosystem. As we move away from the equatorial and arid extremes, we encounter the vast undulating expanses of the grasslands and savannas. These transitional biomes, often found between forests and deserts, are characterized by a dominance of grasses and herbaceous plants, supporting some of the planet's most iconic herds of grazing animals. The Serengeti Mara ecosystem in East Africa exemplifies this. Renowned for the annual great migration of wildebeest, zebras, and gazelles, a spectacular testament to the intricate predator-prey dynamics and the seasonal rhythms of rainfall that dictate the availability of forage. Similarly, the pampas of South America, the steppes of Eurasia, and the prairies of North America, though geographically distant, share this fundamental characteristic. Vast, open spaces where the wind whispers through tall grasses and the horizon stretches endlessly, fostering unique adaptations for both flora and fauna. These are landscapes of cyclical renewal, often shaped by natural fires and the continuous movement of large herbivores. Further towards the poles, and at higher latitudes we enter the domain of the temperate zones, where distinct seasonal changes orchestrate the annual life cycle. Here, the temperate deciduous forests, found across eastern North America, Western Europe, and East Asia, present a breathtaking spectacle of autumnal colour as broadleaf trees shed their foliage in preparation for winter's chill. These forests experience moderate rainfall and temperatures, supporting a rich understory and diverse wildlife. In contrast, the temperate coniferous forests, or taiga, stretch across vast swathes of the northern hemisphere, forming the largest terrestrial biome on Earth. Dominated by cold-tolerant needle-leaved evergreens like spruce, fir, and pine, these forests endure long, cold winters and short, mild summers, their dense canopy creating a unique, hushed environment. And then, at the very edge of the habitable world, we find the tundra, a biome defined by its permafrost, permanently frozen subsoil, and extremely low temperatures. This treeless landscape, found in the Arctic regions and high alpine areas, supports only low-growing vegetation such as mosses, lichens, sedges, and dwarf shrubs, which cling to life during the brief, cool summer. The Arctic tundra, with its vast flat plains, is a fragile ecosystem, yet it supports migratory birds, caribou, reindeer, and a host of resilient small mammals. The alpine tundra, found above the tree line on mountains worldwide, shares similar conditions but is often characterized by rocky terrain and greater topographical variation. Both tundras are sensitive indicators of global climate change, as the thawing of permafrost has significant implications for global carbon cycles and landscape stability. Beyond the broad strokes of these vast biomes, Earth's intricate topography further refines these patterns through vertical zonation, demonstrating how altitude can mirror latitude in its effect on climate and vegetation. As we ascend a towering mountain range, such as the Andes in South America or the Himalayas in Asia, we observe a dramatic succession of life zones. At the base, lush forests might thrive, giving way to temperate woodlands, then to subalpine coniferous forests, until we reach the tree line, beyond which the harsh conditions prevent tree growth. Above this, alpine meadows bloom with hardy wildflowers in summer, transitioning to the barren, rocky expanses of the nival zone, where only sparse lichens cling to life amidst perpetual snow and ice. Each altitudinal band possesses its own unique microclimate, fostering distinct communities of plants and animals adapted to specific temperature ranges, atmospheric pressures, and levels of solar radiation. This vertical layering vividly illustrates Earth's capacity for ecological diversity within a relatively confined geographical space. The geographical isolation, too, plays a profound role in shaping life, a concept beautifully illuminated by the principles of island biogeography. Islands, whether oceanic or continental, often act as evolutionary laboratories, fostering the development of unique species found nowhere else on Earth, a phenomenon known as endemism. Consider the Galapagos Islands, an archipelago arising from volcanic activity in the Pacific Ocean. Their remote location, combined with diverse habitats, led to the evolution of iconic species like Darwin's finches, marine iguanas, and giant tortoises, each adapted to the specific conditions of individual islands. Similarly, Madagascar, a colossal island separated from the African mainland millions of years ago, boasts an astonishing level of endemism, with over 90% of its plant and animal species found exclusively there, including lemurs, unique baobab trees, and countless amphibians and reptiles. These isolated landmasses offer a poignant reminder of the fragility of biodiversity, as their unique ecosystems are particularly vulnerable to introduced species and habitat loss. Throughout this journey across Earth's living tapestry, we cannot help but observe the quiet ingenuity of human adaptation to these diverse geographical settings. For millennia, human civilizations have intricately woven their existence into the fabric of these biomes, developing unique cultures, agricultural practices, and settlement patterns that reflect the opportunities and constraints of their local environment. In the mountainous regions, ancient peoples engineered elaborate tracing systems, like those visible in the rice paddies of Southeast Asia or the agricultural fields of the Inca Empire, transforming steep slopes into productive farmlands and mitigating erosion. In the heart of vast deserts, communities coalesced around precious oses, developing sophisticated irrigation techniques to cultivate crops and sustain life in seemingly inhospitable lands, a testament to collective resourcefulness. Along the coasts and river deltas, fishing communities crafted specialized vessels and techniques, harnessing the bounty of aquatic ecosystems. These interactions, spanning millennia, demonstrate a profound, often reverent connection between humanity and the specific geographical expressions of our planet. As the quietude of this exploration deepens, we hope you feel a renewed sense of wonder for the Earth's exquisite complexity, from the steamy embrace of the rainforest to the austere beauty of the tundra, from the heights of alpine peaks to the isolated wonders of oceanic islands. Each biome is a testament to the planet's dynamic nature and its boundless capacity for life. This vast living tapestry is not merely a collection of disparate regions, but an interconnected system, where every ripple of climate, every shift in geology, and every pulse of life resonates throughout the whole. Allow these images of Earth's living landscapes to settle gently within your consciousness. Recognize the profound beauty, the intricate dance of adaptation, and the quiet wisdom that permeates every corner of our world. As your mind begins its peaceful descent towards rest, carry with you the serene understanding of Earth as a dynamic, breathing entity, perpetually evolving, perpetually inspiring. We are honored that you choose to embark on these contemplative journeys with us, exploring the wonders of geography. If you find peace and fascination in these gentle narratives, a quiet expression of support, perhaps a like or a share, helps us continue to weave these tranquil explorations for you. Tonight, let the images of Earth's vibrant living mantle guide you into a profound and restorative calm. As the gentle currents of our shared exploration carry us onward, we find ourselves drifting from the majestic tapestry of Earth's biomes, where life thrives in myriad forms, to the intricate patterns woven by humanity itself upon this ancient canvas. We have observed how the planet's profound processes sculpt the stage upon which life unfolds, and how its diverse environments invite a spectrum of adaptations from all its inhabitants, including ourselves. Now, as the day gently recedes, inviting a state of calm contemplation, we shift our gaze to the remarkable ways in which human ingenuity, necessity, and aspiration have interacted with these natural settings, transforming them into landscapes that speak volumes of our collective journey. Consider, if you will, the concept of the cultural landscape, a geographical term that encapsulates the visible imprint of human activity on the natural environment. These are not merely places where people live, but rather spaces that have been profoundly modified, imbued with meaning, and shaped by generations of human interaction, reflecting the enduring dialogue between humanity and its physical world. We see this quiet wisdom embedded in the very earth beneath our feet, a testament to our continuous engagement with the planet's resources and challenges. Journey with us to the verdant slopes of the Cordilleras in the Philippines, where the Banawe rice terraces ascend like colossal stairways to the heavens, carved into the mountainsides over 2 millennia ago by the indigenous Ifugao people. These terraces are often hailed as the 8th wonder of the world. Their intricate irrigation system, drawing water from mountain springs and streams, demonstrates a profound understanding of hydraulic engineering and sustainable agriculture, transforming steep, inhospitable terrain into productive farmland. Here, the very contours of the land have been resculpted, not by tectonic forces or fluvial erosion, but by human hands, forming a living testament to an ancient symbiotic relationship with the environment. Similarly, the Andean terracist of Peru, built by pre-Incan and Incan civilizations, allowed for the cultivation of diverse crops at varying altitudes, demonstrating a sophisticated mastery of microclimates and soil management, essentially creating new ecological niches through deliberate geographical modification. Across oceans and continents, another striking example of human landscape engineering manifests in the low-lying nation of the Netherlands. Here, vast tracts of land known as polders have been reclaimed from the sea or lakes through an elaborate system of dikes, canals, and pumping stations. This audacious endeavour, dating back centuries, has expanded the country's habitable and arable land, profoundly altering its coastline and internal geography. The iconic windmills, once integral to dewatering these polders, stand as silent sentinels to this relentless human ambition to redefine the boundary between land and water, demonstrating a persistent effort to literally create geography where none existed before. As our species has grown, so too has its propensity for agglomeration, leading us to the fascinating geography of human settlement, particularly the phenomenon of urbanization. For the first time in human history, over half of the world's population resides in urban areas, a proportion steadily increasing. This demographic shift has profound geographical implications, concentrating human activity, infrastructure, and resource demand into ever-expanding metropolitan regions. Consider the sprawling expanse of Tokyo, the world's largest metropolitan area by population, housing over 37 million inhabitants. Its intricate network of railways, subterranean passages, and towering skyscrapers forms a dense, multi-layered geography, a testament to vertical and horizontal expansion. These urban centres often exhibit unique microclimates, most notably the urban heat island effect, where cities experience significantly warmer temperatures than surrounding rural areas. This phenomenon is a direct result of urban geography. Dark surfaces like asphalt and concrete absorb and retain solar radiation, buildings block wind, and anthropogenic heat is generated by vehicles, industries, and air conditioning systems. This localized climatic alteration is a tangible geographical consequence of human settlement patterns, influencing everything from energy consumption to air quality within urban ecosystems. The very fabric of urban life, from its subterranean infrastructure of pipes and cables to its towering architectural marvels, represents a dramatic reshaping of the Earth's surface. Skyscrapers, for instance, are not merely feats of engineering. They are geographical responses to spatial constraints, allowing for immense population density within a relatively small footprint. They represent a vertical expansion of our built environment, redefining the skyline and creating new ecological niches within the urban biome. Our journey through human geography would be incomplete without acknowledging the profound importance of resource geography. The distribution, extraction, and utilization of the Earth's natural endowments, which fundamentally shape human societies and economies. Though our planet is often called the unquote five, with oceans covering more than 70% of its surface, only about 2.5% of this water is fresh, and a mere fraction of that is readily accessible for human use. This geographical reality of freshwater scarcity is one of the most pressing challenges of our era. Major river basins such as the Nile, the Indus, and the Yellow River have historically cradled civilizations, their fertile floodplains and reliable water sources dictating settlement patterns and agricultural development for millennia. Today, however, many of these crucial waterways face immense pressure from agricultural irrigation, industrial demand, and burgeoning urban populations. We also rely heavily on aquifers, vast underground reservoirs of fresh water. The Mailala Aquifer in North America, for instance, underlies 8 states and is one of the world's largest, providing irrigation for a significant portion of the continent's food supply. Yet, its depletion rate far exceeds its natural recharge, illustrating a profound geographical imbalance between human consumption and natural replenishment. The geography of raw energy resources has profoundly shaped geopolitical landscapes. The uneven distribution of fossil fuels, oil, natural gas, and coal, has been a primary driver of global economics and international relations. The vast oil reserves beneath the Arabian Peninsula, the immense natural gas fields in Russia, and the extensive coal deposits in China and the United States have each dictated patterns of trade, conflict, and development. However, as our understanding of Earth's delicate balance deepens, so too does our pivot towards renewable energy sources, each with its own distinct geographical requirements. Hydropower. Harnessing the kinetic energy of flowing water necessitates large rivers and suitable topography for dam construction, as exemplified by China's Three Gorges Dam, the world's largest power station. Geothermal energy, tapping into the Earth's internal heat, is concentrated in tectonically active regions, making Iceland, situated atop the mid-Atlantic ridge, a global leader in this technology. Solar power thrives in sun-drenched regions, particularly deserts, while wind power is optimally generated in coastal areas, open plains, and offshore locations with consistent strong air currents. These geographical considerations dictate where and how we can best harness the planet's sustainable energy potential, illustrating an evolving and conscious engagement with Earth's dynamic systems. Finally, the distribution of mineral resources is another cornerstone of our modern world. Critical minerals, from rare earth elements essential for electronics, to copper vital for infrastructure and diamonds prized for their beauty and industrial utility, are not uniformly scattered across the globe. Their geological formation dictates their presence in specific regions, leading to complex global supply chains and economic interdependencies. The vast open-pit mines necessary for extracting these valuable elements represent some of the most dramatic human alterations of the Earth's surface, creating immense geographical scars that speak to the scale of our material demands. As we conclude this segment of our journey, we are reminded that human civilization is not merely an observer of geography, but an active participant in its ongoing creation. From the ancient terraces that contour mountainsides to the towering skylines of megacities, from the reclaimed lands that defy the sea to the intricate networks that draw water and energy from deep within the earth, we continuously sculpt, organize, and transform our planet. These human-made geographies, though often overlooked in their quiet ubiquity, are as much a part of Earth's grand narrative as its mountains and oceans. We invite you to carry these reflections into your quiet moments, allowing the intricate dance between humanity and the Earth to settle gently within your thoughts. As you drift towards repose, consider the profound beauty and complexity of these intertwined systems, and perhaps allow a sense of wonder to accompany you into the calm embrace of rest. We will meet again, ready to uncover yet more of Earth's quiet wisdom and remarkable diversity. As the day gently recedes, inviting the quietude that settles upon the world, we continue our tranquil journey across the intricate tapestry of our planet. Having journeyed through the foundational elements of Earth's grand blueprint, its aqueous and atmospheric envelopes, the profound geological processes shaping its very form, the vibrant biomes that teem with life, and the indelible imprints of humanity's resource utilization, we now turn our contemplative gaze to the arteries of global connectivity. Tonight, we observe how these critical resources, and indeed all facets of human endeavor, traverse the vast distances of our dynamic sphere, binding continents and cultures in an ever-evolving embrace. Consider, if you will, the ceaseless flow of global trade, a monumental dance of goods and ideas facilitated by an astonishing network of geographical conduits. At the very heart of this intricate system lie the vital waterways, those strategic passages that dramatically reconfigure the planet's vastness. The Suez Canal, a monumental feat of human engineering inaugurated in 1869, stands as a testament to our capacity to reshape geography. This artificial sea-level waterway, approximately 120 miles in length, effectively severs the ancient land bridge between Africa and Asia, creating a direct maritime link between the Mediterranean Sea and the Indian Ocean via the Red Sea. Its existence drastically curtails the arduous journey around the Cape of Good Hope, a perilous voyage that once defined global commerce. The geographical impact is profound, compressing distances and fostering unprecedented economic interdependence between East and West, a silent testament to the enduring power of location and access. Similarly, the Panama Canal, another marvel of human ingenuity inaugurated in 1914, carves a 50-mile path through the Isthmus of Panama, connecting the Atlantic Ocean via the Caribbean Sea to the Pacific Ocean. This complex system of locks elevates vessels across the continental divide, circumventing the immense journey around the treacherous Cape Horn at the southern tip of South America. The canal's strategic position has fundamentally reshaped global maritime logistics, transforming trade routes and solidifying Panama's pivotal role in international commerce. These canals are not merely waterways, they are geographical fulcrums, exerting immense influence over global geopolitics and economic flows, silently dictating the rhythm of maritime traffic for container ships, oil tankers, and bulk carriers that form the lifeblood of our interconnected world. Beyond these engineered arteries, nature has also bestowed upon us critical maritime choke points, narrow channels or straits that concentrate global shipping traffic, rendering them strategically vital. The Strait of Malacca, for instance, a slender 550-mile stretch between the Malay Peninsula and the Indonesian island of Sumatra, serves as one of the most crucial shipping lanes in the world. Annually, it witnesses the passage of over 80,000 vessels, including a significant portion of the world's oil shipments, linking major Asian economies with the Middle East and Europe. Its geographical constriction underscores its immense strategic importance, a fact keenly understood by nations worldwide. Similarly, the Strait of Hormuz, connecting the Persian Gulf to the Arabian Sea, is another indispensable bottleneck for the global oil supply, an eloquent illustration of how geography can dictate geopolitical leverage. These passages, both natural and artificial, form an invisible yet immensely powerful web, binding the disparate corners of our Earth into a singular, dynamic economic entity. But the intricate dance of global connectivity extends far beyond the oceans. Across vast continental expanses, transcontinental railways carve their own paths, facilitating the movement of goods and people on an immense scale. The legendary Trans-Siberian Railway, stretching over 5,700 miles from Moscow to Vladivostok, remains the longest railway line in the world, a colossal artery that stitches together the immense breadth of Eurasia, opening up vast interior regions to trade and settlement. In our contemporary era, ambitious initiatives like the Belt and Road Initiative further illustrate humanity's enduring drive to overcome geographical barriers, proposing a sprawling network of land and sea routes designed to enhance connectivity and foster economic integration across continents. These iron pathways traversing mountains and plains represent the terrestrial capillaries of our global circulatory system, and then there are the unseen highways of the sky and the ocean depths. Air cargo and passenger routes crisscross the atmosphere with astonishing frequency, creating a vibrant, ephemeral network that compresses time and space. From the bustling hubs of international airports, goods of high value and urgency, alongside millions of travellers, are whisked across continents in mere hours, a testament to technological prowess overcoming the planet's vastness. Beneath the waves, an even more fundamental network hums with silent efficiency, the sprawling matrix of submarine fibre optic cables. These delicate yet resilient strands, laid across ocean floors, form the digital backbone of our modern world, transmitting vast quantities of data, from financial transactions to instantaneous communication at the speed of light. Without these submerged conduits, the very notion of a globally interconnected digital society would be rendered impossible. They are the unseen nerves of our planetary consciousness. This profound interconnectedness finds its most vibrant expression in our urban centres, which serve as the dynamic nodes within this global web. While we briefly touched upon urbanisation in a previous contemplation, let us now consider megacities not merely as concentrations of population, but as pulsating hubs of global interaction, their geographical attributes often dictating their prominence. Cities like Hong Kong and Singapore, for instance, owe much of their unparalleled economic vitality to their strategic coastal locations and deep water harbours, providing natural gateways for maritime trade. Their geographical advantage has allowed them to evolve into global financial powerhouses and logistical epicentres, processing immense volumes of goods and capital. Even landlocked cities, through their sophisticated infrastructure of airports and railway networks, become crucial conduits, demonstrating the ingenuity with which humanity can mitigate inherent geographical limitations. The very architecture of these cities, with their vertical aspirations and subterranean networks, reflects an ongoing dialogue with their constrained geographical footprints, a testament to humanity's adaptive spirit. The distribution of these urban centres, and indeed of humanity itself across the Earth's surface, is a fascinating study in population geography. We observe distinct patterns. Dense concentrations often cluster along fertile river valleys, such as the Nile or the Ganges, where arable land and freshwater are abundant. Coastal plains, offering access to maritime trade and milder climates, also draw immense populations. Conversely, vast arid deserts, towering mountain ranges and polar ice caps remain sparsely inhabited, stark reminders of environmental constraints. Yet, even within these patterns, humanity is in constant motion, migration. Both internal and international is a fundamental geographical phenomenon, driven by a complex interplay of push factors, such as conflict, poverty, or environmental degradation, and pull factors, like economic opportunity, political stability, or family reunification. These movements redraw demographic maps, reshape cultural landscapes, and create intricate networks of remittances, money sent home by migrants, which often form a significant economic lifeline for their countries of origin, demonstrating the profound human and economic reach of geographical displacement. The recent decades have also underscored the geographical challenge of refugee movements, where millions are displaced across borders, creating humanitarian crises that are inherently geographical in their scope and impact. These movements of people, ideas, and goods profoundly shape our cultural and linguistic landscapes. As populations migrate, they carry with them their traditions, languages, and belief systems, leading to the fascinating phenomenon of cultural diffusion. Over millennia, this process has forged the rich mosaic of human cultures we observe today. However, physical geography often acts as a powerful determinant in this diffusion. Consider the extraordinary linguistic diversity of Papua New Guinea, a nation renowned for speaking over 800 distinct languages within its borders. This unparalleled variety is directly attributable to its exceptionally rugged and mountainous terrain, which historically isolated communities, allowing unique linguistic and cultural identities to flourish independently. Mountains, rivers, and vast oceans have long served as both barriers and conduits, influencing the spread and preservation of distinct cultural hearths and linguistic families, creating a complex, layered map of human expression across the globe. Finally, as we reflect on humanity's pervasive presence and intricate interconnectedness, let us marvel at our species' remarkable capacity for adaptation, pushing the very boundaries of human habitation. On the high Andean plateau of Peru, at an astonishing elevation of over 16,700 feet, 5,100 meters, lies La Rinconada, often cited as the highest permanent human settlement in the world. Its inhabitants, drawn by the lure of gold mining, endure extreme cold, thin air and harsh conditions, a testament to human resilience in the face of physiological challenges. In stark contrast, beneath the sun-baked earth of the Australian outback, the town of Kuba Pedy offers a unique solution to extreme heat. Its residents live predominantly in dugouts carved into the sandstone, creating subterranean homes that maintain a consistently cool temperature. This underground existence is a brilliant geographical adaptation to one of Earth's most unforgiving climates. Venturing to the frigid extremes, we find Oymyakon, Russia, a village in Siberia that holds the undisputed title of the coldest permanently inhabited place on Earth, with recorded temperatures plummeting to 90 degrees, 67.7 degrees. Life here is a continuous battle against the elements, a testament to the sheer tenacity of human will. Conversely, in the scorching Danakil Depression of Ethiopia, near the Dalol hydrothermal field, temperatures regularly soar above 100 degrees, 30 ischian, even in winter, making it one of the hottest places on Earth with sustained human presence, albeit often transient for mining purposes. These extreme settlements are not merely curiosities, they are living laboratories of human adaptability, showcasing our species' profound ability to carve out existence in the most challenging geographical niches. As our contemplative journey through these pathways of human connectivity and resilience draws to a gentle close for this evening, we hope that these glimpses into the profound interplay between humanity and its geographical stage have offered you moments of calm contemplation and renewed wonder. The Earth, in its grand design, continues to reveal its quiet wisdom, inviting us to appreciate the intricate dance of its natural processes and the remarkable ingenuity of its inhabitants. We are but threads in this magnificent tapestry, woven into the very fabric of this dynamic planet. If these shared insights have brought a measure of peace and curiosity to your evening, we encourage you to join us again as we continue to unravel the remaining wonders of our world. For now, may your mind drift peacefully with these geographical currents, preparing you for a restful night, as the day gently recedes, inviting the quietude that precedes true rest. We find ourselves drawn deeper into the intricate tapestry of our planet, moving beyond the remarkable resilience of human settlements to consider the profound interwoven systems that sustain all life. Our journey, an unhurried exploration of Earth's grand blueprint, now turns its gaze towards the delicate, often unseen mechanisms that orchestrate the very breath and being of our world. We invite you to continue this gentle discovery, allowing the complex elegance of geographical processes to settle upon you, not as a burden of facts to be retained, but as a soothing current of understanding. Tonight, our contemplation embraces the subtle yet monumental dance of biogeochemical cycles, the grand planetary choreography of elements essential for life. Consider, if you will, the carbon cycle, a testament to Earth's dynamic nature, where carbon atoms embark on an eternal odyssey, transitioning from the atmospheric embrace of carbon dioxide to the organic structures of living beings, into the depths of oceans and the ancient reservoirs of fossil fuels, only to return once more to the air. Photosynthesis, that miraculous alchemy performed by terrestrial plants and marine phytoplankton, draws atmospheric carbon into the biosphere, anchoring it within the intricate food webs that define ecosystems. When these organisms respire or decompose, carbon returns to the atmosphere or becomes sequestered in soils and sediments, eventually forming the coal, oil, and natural gas deposits that lie deep within Earth's crust. This delicate equilibrium, maintained over eons, underscores the planet's self-regulating genius, a system finely tuned to support the vast diversity of life we observe. Parallel to this, the nitrogen cycle unveils another fundamental truth of our living world, demonstrating how an inert atmospheric gas, comprising nearly 78% of the air we breathe, is transformed into biologically available forms. Through the diligent work of specialized microorganisms, nitrogen is fixed into ammonia and nitrates, becoming the foundational nutrient for proteins and nucleic acids, the very building blocks of life. This transformed nitrogen then cycles through soils, plants, and animals, eventually returning to the atmosphere through denitrification, completing a loop vital for ecological productivity. These cycles, along with the ubiquitous water cycle, the continuous movement of water above, on, and below the surface of the Earth, driven by solar energy and gravity, are not isolated phenomena but intimately interconnected, each influencing and being influenced by the others, forming a global network of life support. The oceans, vast and enigmatic, play a particularly crucial role as immense carbon sinks, absorbing a significant portion of atmospheric carbon dioxide, a process vital in moderating Earth's climate, though not without consequences for marine ecosystems, as we shall soon observe. Within these life-sustaining cycles we find pockets of extraordinary vitality, thus to biodiversity hotspots. These are not merely regions rich in species, but specific geographical areas that harbour a high concentration of endemic species, those found nowhere else on Earth, and have experienced significant habitat loss. Places like the Madagascar and Indian Ocean islands, the tropical Andes, and the Cerrado of Brazil exemplify these vibrant yet vulnerable regions. Their geographical isolation, unique climatic conditions, and complex interactions of species have fostered an unparalleled evolutionary crucible, yet their precarious status serves as a poignant reminder of the fragility inherent in such concentrated ecological wealth. Understanding their geographical boundaries and ecological functions is paramount, for their preservation is inextricably linked to the health of the global ecosystem. However, the quiet wisdom embedded in these ancient processes now faces unprecedented challenges, largely stemming from the accelerated pace of human activity. Our collective footprint has begun to alter these fundamental cycles, pushing Earth's systems beyond their historical ranges of variability. We now turn our attention to the geographical manifestations of climate change, a phenomenon reshaping our planet with a swiftness that compels our contemplation. The scientific consensus is clear. The observed warming trend is unequivocal, and human influence on the climate system is undeniable, primarily through the release of greenhouse gases from the burning of fossil fuels and land use changes. The geographical evidence of this transformation is stark and widespread. Consider the dramatic glacial retreat occurring across the globe, from the majestic peaks of the Himalayas to the expansive ice sheets of Greenland and Antarctica. These colossal rivers of ice, once thought immutable, are now visibly shrinking, their meltwaters contributing to a relentless sea level rise. Coastal cities and low-lying island nations such as the Maldives or Tuvalu face the existential threat of inundation, necessitating geographical adaptation strategies from engineered defences to planned relocations. The very shorelines that have defined human settlement for millennia are being redrawn by the relentless encroachment of the sea, a profound geographical alteration occurring within a single human generation. Beneath the waves, the oceans, those silent custodians of Earth's climate, are also undergoing profound shifts. The increased absorption of atmospheric carbon dioxide, while mitigating some terrestrial warming, leads to ocean acidification. This chemical change, a decrease in seawater pH, imperils marine life, particularly organisms that build shells and skeletons from calcium carbonate, such as corals and shellfish. The vibrant coral reefs, often referred to as the rainforests of the sea, due to their immense biodiversity, are especially vulnerable, experiencing widespread coral bleaching. events as ocean temperatures rise, threatening the intricate ecosystems they support and the coastal protection they provide. Across continents, altered weather patterns are manifesting as more frequent and intense extreme events. We observe prolonged droughts in agricultural heartlands, exacerbating water scarcity and threatening food security in regions already vulnerable. Conversely, unprecedented flooding events devastate communities situated along major river systems and coastlines, overwhelming existing infrastructure and displacing populations. The intensification of tropical storms and hurricanes, drawing energy from warmer ocean waters, brings more destructive winds and torrential rains to coastal zones, demonstrating the direct geographical impact of a warming world. These shifts are not merely meteorological anomalies. They represent a fundamental reordering of regional climates, challenging established agricultural practices, water management strategies, and human settlement patterns. Furthermore, we are witnessing the shifting of climate zones, and consequently, the geographical distribution of biomes. Species, both flora and fauna, are migrating towards poles or higher altitudes in an attempt to track their preferred climatic conditions, leading to novel ecological assemblages and placing immense pressure on those species unable to adapt or move quickly enough. The delicate balance of ecosystems is disrupted, threatening biodiversity and altering the very character of landscapes. The boreal forests, for instance, are expanding northward into the tundra, while deserts are encroaching upon grasslands, a palpable geographical transformation unfolding before our eyes. These multifaceted changes underscore the concept of tipping points. In Earth systems, thresholds beyond which a system undergoes irreversible changes, the collapse of major ice sheets, the dieback of the Amazon rainforest, or the sustained loss of permafrost, releasing vast quantities of stored carbon and methane, are examples of such potential tipping points. Their geographical implications are immense and global, highlighting the interconnectedness of our planetary systems and the critical need for careful stewardship. In response to these profound geographical challenges, humanity is beginning to craft a narrative of conservation geography and sustained human response. The establishment of protected areas, such as national parks and wildlife reserves, represents a deliberate geographical strategy to safeguard critical habitats and biodiversity. These areas, often strategically located within biodiversity hotspots or along migratory routes, serve as vital refuges for threatened species and provide essential ecosystem services. Moreover, the concept of transboundary conservation, where protected areas span international borders, exemplifies a collaborative geographical approach to environmental challenges, recognizing that ecosystems do not adhere to political lines. Efforts to create ecological corridors, strips of habitat that connect isolated protected areas, are also gaining prominence. These geographical linkages allow species to move between fragmented landscapes, enhancing genetic diversity and improving resilience to climate-induced shifts. We see this in initiatives aimed at reconnecting fragmented forest patches in Central America or creating wildlife bridges over busy highways, demonstrating an evolving understanding of landscape connectivity. The Amazon rainforest, a geographical marvel and a global lung, stands as a poignant example of both immense ecological value and severe environmental pressure. Efforts to combat deforestation, here involve complex geographical analyses, utilizing tools like remote sensing and geographic information systems, GIS, to monitor forest cover, track illegal logging, and identify areas for reforestation. These technologies offer an unprecedented ability to visualize and analyze geographical data, providing critical insights for conservation planning and environmental management on scales from local to global. Similarly, the ongoing struggle to protect the Great Barrier Reef from the impacts of coral bleaching involves extensive marine spatial planning, research into coral resilience, and international efforts to reduce global greenhouse gas emissions, a truly global geographical challenge demanding a global response. Ultimately, our collective journey through these 100 incredibly interesting geography facts culminates in a profound recognition of humanity's role as stewards of this magnificent planet. The geographical challenges we face are immense, yet so too is our capacity for ingenuity, adaptation, and collaborative action. The future of our planet's geography, in its broadest sense, rests upon the choices we make today. As we conclude this chapter, we invite you to reflect on these intricate systems, on the quiet dynamism of Earth, and on the enduring beauty of its processes. Allow this contemplation to bring a sense of peace, knowing that understanding is the first step toward harmonious coexistence. Tonight, we rest, carrying with us the vastness of the world, gently held within our minds. We have journeyed through the grand narratives of our planet, observing the colossal forces that sculpt its surface and the intricate systems that sustain life. We have contemplated the profound challenges facing our biosphere and the hopeful endeavors of conservation. Now, as the day gently recedes, inviting a deeper sense of tranquility, let us turn our gaze to some of the more intimate, yet no less astonishing, details etched into Earth's remarkable canvas, the subtle brushstrokes that reveal the planet's ceaseless artistry, often in places less traversed, yet brimming with quiet wisdom. Imagine, if you will, the dynamic interface where land meets sea, a realm of perpetual transformation and breathtaking power. Here, the ocean, in its rhythmic embrace of the shore, reveals phenomena of singular grandeur. Consider the tidal bore, a truly captivating spectacle, where the leading edge of an incoming tide forms a wave, or series of waves, that travels upstream against the current of a river or narrow bay. The most renowned of these, the Kentang River tidal bores in China, can surge inland with a thunderous roar, reaching heights of several meters, a formidable aquatic wall that demonstrates the sheer gravitational might exerted upon our oceans. This dramatic surge is a testament to the intricate interplay of lunar and solar forces, funneled and amplified by the precise geomorphology of a river estuary, creating a transient yet powerful river wave that defies the river's usual flow. Beyond such dramatic surges, the coastline itself is a testament to relentless geological sculpting. We observe the patient work of coastal erosion, where the ceaseless pounding of waves laden with abrasive sediments carves magnificent features into resistant rock. Here, sea arches stand as monumental gateways, often remnants of ancient sea caves whose roofs have collapsed, leaving behind a graceful span. Nearby, isolated sea stacks rise majestically from the surf, solitary sentinels that once formed part of a headland, now separated from the mainland by the relentless retreat of the cliffs. These formations, like the iconic 12 Apostles along Australia's shipwreck coast, or the dramatic stacks of Etretat in France, are fleeting masterpieces, their existence a continuous dialogue with the erosive power of the sea, destined one day to crumble and return to the sandy depths from which they were forged. Simultaneously, the complementary process of coastal deposition builds and reshapes, forming vast stretches of sandy beaches, intricate barrier islands that migrate and evolve with storms and currents, and the fertile sprawling deltas where great rivers surrender their sediment load to the sea, creating new land and rich ecosystems. Our journey then carries us beyond the continental margins to the myriad islands scattered across the vast oceanic expanse, each a unique microcosm of life and geology. These isolated land masses, often born of volcanic fire or the patient accretion of coral polyps, offer profound insights into evolutionary processes and the remarkable adaptability of life. Consider the formation of atolls, those breathtaking rings of coral reef that encircle a central lagoon. Their genesis is a slow, majestic ballet. A volcanic island emerges from the deep, fringing reefs begin to grow around its shores, and as the volcano gradually subsides beneath the waves, a process spanning millions of years, the coral continues to build upwards, maintaining its proximity to the sunlit surface. Eventually, the volcanic peak vanishes, leaving behind a vibrant living ring of coral surrounding a placid lagoon, a truly organic architecture. The Maldives and Tuvalu are exquisite examples of such atolls, profoundly beautiful yet acutely vulnerable to the rising tides of a changing climate. Contrast these oceanic marvels with continental islands, land masses like Madagascar or New Zealand, which were once connected to larger land masses before geological rifting or sea level changes separated them. Their unique biotas, often characterized by high levels of endemism, species found nowhere else on Earth, are living laboratories of divergent evolution, a testament to the power of geographical isolation in shaping the tree of life. Imagine the ancient baobabs and lemurs of Madagascar, or the flightless birds and unique flora of New Zealand, each a living relic, a testament to millions of years of isolated evolutionary pathways. From the sun-drenched surface, let us now descend into the Earth's hidden depths, a realm of silent subterranean wonders. Beneath our feet lies an intricate network of caves, carved over eons by the patient work of water, percolating through soluble rock, primarily limestone. In these dark, hushed chambers, gravity and chemistry conspire to create breathtaking formations known as speleothems. Stalactites hang like frozen tears from the cave ceiling, formed by mineral-rich water dripping downwards, while stalagmites rise from the floor, built by the accumulation of these same mineral deposits. Pillars, curtains and flowstones adorn these subterranean cathedrals, each a testament to unimaginable spans of geological time. The Mammoth Cave System. In Kentucky, USA, the longest known cave system in the world, stretches for hundreds of miles, a labyrinthine marvel that continues to yield new discoveries, revealing the profound complexity of subterranean hydrology and geology. Beneath the very soil we tread, vast aquifer systems store and transport immense quantities of fresh water, often accumulated over millennia. The Great Artesian Basin, In Australia, one of the largest and deepest artesian basins in the world, underlies nearly a quarter of the continent, a vital subterranean reservoir supporting life in arid landscapes. These hidden rivers and lakes are not merely static reserves. They are dynamic components of the global hydrological cycle, interacting with surface waters and supporting unique ecosystems adapted to perpetual darkness. Returning to the surface, our attention might be drawn to more ephemeral, yet equally captivating hydrological phenomena. Consider the Okavango Delta. In Botswana, a truly extraordinary inland delta where a vast river, instead of flowing to the sea, disperses its waters across a flat alluvial fan in the Kalahari Desert. This annual inundation transforms a parched landscape into a verdant, teeming wetland, a seasonal oasis that supports one of Africa's most concentrated populations of wildlife. Its existence is a geographical anomaly, a testament to the power of topography and climate to redirect the grand flow of water, creating a vibrant, transient Eden. Similarly, in other arid regions, ephemeral lakes, such as Lake Ayres in Australia, lie as vast salt pans for much of the year, only to fill dramatically after rare, heavy rains, briefly becoming the largest lake on the continent and attracting immense flocks of migratory birds, before slowly evaporating back into a shimmering saline expanse. And what of the visual spectacles offered by water? Some lakes defy the conventional hues of blue or green, presenting a palette of the extraordinary. Lake Hillier, in Western Australia, for instance, mesmerises with its startling bubblegum pink waters, a phenomenon attributed to the presence of Dunaliella salina microalgae and halophilic bacteria in its highly saline environment. Or consider Laguna Colorada. In Bolivia, a shallow, intensely red lake, its vibrant colour derived from a combination of red sediments, pigmented algae, and other microorganisms, often dotted with white borax islands, creating a surreal, otherworldly landscape that seems painted by a divine hand. As we traverse these diverse landscapes, let us not forget the profound artistry of wind and sand in Earth's arid zones. Beyond the vastness of the great deserts, we find an intricate world of dunes, each type a sculptural masterpiece shaped by the prevailing winds and sand supply. Barchan dunes, crescent-shaped and constantly migrating, march across the desert floor like silent armies. Safe dunes, or longitudinal dunes, stretch for miles in parallel ridges, aligned with the dominant wind direction. And the majestic star dunes, towering pyramids of sand with radiating arms, are formed by complex multi-directional wind patterns. These colossal, shifting forms are not static. They are living structures, their surfaces rippled by the wind, sometimes even producing a low, resonant hum, the phenomenon of singing sands, as grains slide down their slopes, creating an ethereal desert music. And in the most extreme aridities, where ancient lakes have long since evaporated, we encounter the mesmerizing expanse of salt flats. The Serra de Uyuni in Bolivia, the world's largest salt flat, stretches over 10,000 square kilometers, a vast, blindingly white expanse that becomes a colossal mirror during the rainy season, reflecting the sky in a breathtaking illusion of infinite space. This ancient lake bed, rich in lithium and other minerals, is a testament to immense geological and climatic shifts, a starkly beautiful, yet profoundly significant geographical feature. As our gentle journey through these myriad geographical wonders continues, we find ourselves enveloped in a sense of profound appreciation for the Earth's boundless creativity. Each fact, each description is but a small window into the grand blueprint, a delicate thread in the intricate tapestry of our planet. We invite you to carry these images, these quiet observations, into your moments of calm, allowing them to deepen your connection to the world around you, fostering a peaceful contemplation that prepares you for the restorative embrace of rest. The Earth, in its tireless motion and endless transformation, offers an inexhaustible wellspring of wonder, waiting patiently for our quiet attention. And as we drift towards the gentle threshold of slumber, we will observe yet more of its remarkable diversity, tonight and in the chapters yet to unfold. As the gentle currents of our shared journey continue to guide us across the vast, intricate tapestry of our planet, we find ourselves once more poised on the precipice of discovery. Having traversed the intimate details of coastal fringes, the solitary majesty of islands, the profound silence of subterranean realms, and the stark beauty of arid wonders, we now turn our gaze towards phenomena that often escape the casual observer, those ephemeral whispers of atmosphere, the enigmatic paths of water, and the silent, enduring artistry of stone. Allow your consciousness to drift, to unfurl like a delicate sail catching the softest breeze, as we delve into these less trodden, yet equally captivating geographical marvels. There is no urgency here, only the tranquil invitation to observe, to wonder, and to absorb the quiet wisdom embedded within Earth's dynamic narrative. Our exploration begins not on solid ground, nor within the liquid embrace of oceans, but amidst the ethereal expanse of our atmosphere, where light and air conspire to weave illusions of breathtaking beauty. We invite you to contemplate the phenomenon known as the Fata Morgana, a complex form of superior mirage that transforms distant objects, be they coastlines, islands, or even ships, into distorted, elongated, and often inverted images, seemingly suspended above the horizon. This optical marvel arises when rays of light bend sharply as they pass through layers of air of differing temperatures, with warmer air overlying cooler air, creating a thermal inversion. The effect is not merely a hazy shimmer, but a distinct multi-layered projection, often appearing as towering castles or fantastical cities, shimmering briefly before dissolving back into the distant reality. Geological conditions such as the flat, expansive surface of a calm sea or a large, cold landmass are often prerequisites for the formation of the precise atmospheric stratification necessary for this intricate dance of light and temperature to unfold. It is a poignant reminder that even the air we breathe holds secrets, capable of conjuring landscapes from mere light and heat, blurring the very lines between perception and reality. From these shimmering atmospheric illusions, we elevate our perspective to observe the skies themselves, where clouds, those transient architects of the firmament, sometimes assume forms of extraordinary elegance. Consider, if you will, the testicular cloud, a distinctive lens-shaped cloud formation that typically develops in the troposphere, often found stationary in the lee of mountains or mountain ranges. These iridescent saucer-like structures are born when moist air flows stably over a mountain barrier, creating standing waves in the atmosphere. As the air rises and cools at the crest of these waves, moisture condenses into these smooth, often iridescent clouds, only to evaporate again as the air descends into the trough. Their serene, stacked appearance, sometimes resembling a pile of plates or even the iconic imagery of unidentified flying objects, speaks to the invisible undulations of air currents, a testament to the complex interplay of topography and atmospheric dynamics. They are silent sentinels, marking the invisible currents of our planet's breath, a truly mesmerizing geographical fact etched against the vast canvas of the sky. And as the day gently recedes or gracefully begins, there are moments, fleeting and precious, when the very edge of the sun offers a final emerald farewell or a nascent verdant greeting. We speak, of course, of the green flash, a rare optical phenomenon that occurs just at the moment of sunset or sunrise, when a sliver of green light briefly appears above the upper limb of the sun, or a green ray shoots up from the sunset point. This captivating display is a consequence of atmospheric refraction, where the Earth's atmosphere acts like a prism, splitting sunlight into its constituent colours. Because blue and green light are refracted more strongly than red and yellow light, and are scattered more easily, under very specific conditions of a clear horizon and stable atmospheric layering, the green component can momentarily become visible as the last or first light of the sun dips below or rises above the horizon. It is a whisper of hidden colour, a geographical secret unveiled only to the patient and the observant, a jewel momentarily revealed by the grand celestial mechanics of our solar system. Continuing our celestial observations, we shift our gaze to more turbulent, yet equally fascinating cloud formations. We invite you to envision the Yamamatus cloud, a unique cellular pattern of pouches hanging beneath the base of a cloud, most often cumulonimbus clouds, which are associated with severe weather. These distinctive bulbous protuberances are formed by sinking air within the cloud, in contrast to most clouds which form from rising air. The precise mechanism is still a subject of scientific inquiry, but it is believed to involve the evaporation of precipitation-cooled air within the cloud, creating pockets of denser, cooler air that sink and form these characteristic undulating lobes. Their appearance, often likened to an otherworldly undulating underside, serves as a dramatic visual cue to the immense complex forces at play within powerful storm systems, revealing the intricate dance of thermodynamics and fluid dynamics high above our heads. They are a profound geographical statement, demonstrating the raw, sculptural power of the atmosphere. As we descend from the atmospheric ballet, our contemplative journey now leads us to the enigmatic pathways of water, exploring rivers that defy conventional expectation. Let us delve into the mysterious world of the subterranean rivers. Those hidden arteries that carve their way through the Earth's crust, often in vast cave systems. These unseen waterways are particularly prevalent in karst landscapes, where soluble bedrock, primarily limestone, is dissolved by acidic groundwater, creating a labyrinthine network of caves, sinkholes, and underground channels. These rivers can flow for miles beneath the surface, sometimes emerging as springs or rejoining surface rivers, carrying sediments and shaping the subterranean environment in profound ways. Examples like the Rio Secreto in Mexico or the numerous underground rivers feeding the cenotes of the Yucatan Peninsula offer a glimpse into these inverted hydrological systems, where light never touches the flowing water and unique ecosystems thrive in perpetual darkness. They remind us that the hydrological cycle is not merely a surface phenomenon, but a multi-dimensional process, deeply intertwined with the very geological fabric of our planet. Further challenging our conventional understanding of fluvial systems, we encounter the rare and intriguing phenomenon of a river bifurcation. This occurs when a single river splits into two or more separate channels that flow into different drainage basins, ultimately leading to different seas or oceans. One of the most celebrated and geographically significant examples is the Casiquiare Canal in Venezuela, which connects the Orinoco River Basin with the Amazon River Basin. Here, a portion of the Orinoco's waters diverts naturally into the Casiquiare, which then flows into the Rio Negro, a tributary of the Amazon. This remarkable natural canal serves as a living illustration of the subtle, yet profound, interconnections within continental hydrological networks, demonstrating how these seemingly distinct boundaries of watersheds can, in fact, be fluid and interconnected, a testament to the grand interconnected blueprint of Earth's water systems. And then there are rivers that, rather than flowing into another body of water, simply choose to vanish. We speak of disappearing rivers, waterways that, in specific geological contexts, particularly in karst regions, flow into sinkholes or swallow holes, effectively vanishing beneath the Earth's surface. These rivers continue their journey as subterranean streams, sometimes re-emerging miles away as powerful springs, or feeding into vast underground aquifers. The disappearance is not always permanent, as some re-emerge further downstream. This dramatic act of hydrological vanishing acts as a powerful demonstration of the porosity of certain landscapes, where the surface hydrological network is merely an upper layer of a much more complex hidden system. It is a profound geographical secret, revealing the Earth's capacity to absorb and redirect vast quantities of water, reshaping landscapes from within. Having navigated the atmospheric and hydrological enigmas, we now turn our attention to the enduring artistry of the Earth's lithosphere, where geological forces sculpt stone into forms of astonishing beauty and mathematical precision. Let us marvel at the set basalt columns, striking geological formations that arise from the cooling and contraction of lava flows. As molten basaltic lava cools, it shrinks, and if the cooling occurs uniformly, it typically fractures into polygonal columns, most commonly hexagonal. This process, known as columnar jointing, creates breathtaking landscapes such as the Giant's Causeway in Northern Ireland, where thousands of perfectly formed hexagonal columns rise from the sea, or the Devil's Tower in Wyoming, a monolithic tower composed of these vertical pillars. These structures are not merely rocks. They are the frozen echoes of ancient volcanic eruptions, a testament to the Earth's fiery past and its intricate geological processes, presenting a geometrically perfect natural architecture. From these grand columnar structures, we shift our focus to more whimsical, yet equally impressive erosional forms, the hoodoos and fairy chimneys. These tall, thin spires of rock protrude from the bottom of arid basins and badlands, often resembling fantastical figures or chimneys. Their formation is a testament to differential erosion, where a resistant caprock, a harder, less erodible layer of rock, protects the softer rock directly beneath it from erosion by wind and water. Over millennia, as the surrounding softer material erodes away, these protected columns are left standing, often with their distinctive Quote 11. Iconic examples include Bryce Canyon National Park in Utah, with its vast amphitheaters filled with thousands of these vibrant red-orange spires, and the otherworldly landscapes of Cappadocia in Turkey. They are nature's sculptures, each a unique geographical fingerprint, telling a silent story of wind, water, and varying rock resistance. And what of the very ground beneath our feet? Can it sing? Indeed, in rare and specific locales, we find the phenomenon of singing sands or booming dunes. These are sand dunes that emit a distinct, resonant sound, sometimes a low hum, sometimes a higher-pitched squeak or roar, when disturbed by wind or human movement. The precise conditions required for this acoustic marvel are quite specific. The sand grains must be of a particular size, between 0.1 and 0.5 mm in diameter, almost perfectly spherical, and coated with a very thin layer of silica. Furthermore, the sand must be extremely dry and loosely packed. When these conditions align, the friction between the grains as they slide over one another creates vibrations that are amplified by the dune structure, producing the ethereal, almost musical sounds. It is a geographical whisper from the desert, reminding us that even the seemingly inert elements of our planet possess hidden sensory dimensions. Our contemplative journey now takes us to a feature of such immense scale that it is best appreciated from orbit, the Urchet structure, often called the Eye of the Sahara. Located in Mauritania, this deeply eroded, dome-shaped geological structure is a striking circular feature, approximately 40 kilometers, 25 miles in diameter, with concentric rings of alternating resistant and less resistant rock layers. Initially thought to be an impact crater, detailed geological studies have since revealed it to be a deeply eroded domal uplift, a symmetrical anticline that has been exposed over vast geological timescales. The differential erosion of its various rock layers has created the distinctive bullseye pattern, making it an unmissable landmark from space. It is a grand, silent testament to the immense forces of geological uplift and the relentless, patient work of erosion, a colossal geographical fingerprint etched into the vast desert canvas. Finally, we consider the extraordinary landscapes known as stone forests. These remarkable geological formations are characterized by vast areas of sharp, towering limestone pinnacles, often densely packed and intricately carved by millennia of dissolution and erosion, found predominantly in karst regions such as the Shilin stone forest in Yunnan, China, or the Singhi de Bemaraha National Park in Madagascar. These forests are not composed of trees, but of dramatic, razor-sharp rock formations that can reach tens or even hundreds of feet in height. The process involves the dissolution of soluble limestone by rainwater, which seeps into cracks and fissures, slowly widening them over geological time, leaving behind these spectacular blade-like spires. Navigating these landscapes is like entering an alien world, a maze of petrified sentinels, each a testament to the slow, inexorable power of water and time. They are profound geographical expressions, revealing the Earth's capacity for creating landscapes of unparalleled sculptural complexity and beauty. As the echoes of singing sands and the visions of green flashes gently recede, and the profound artistry of stone forests settles within your mind, We trust that this exploration of Earth's more subtle, yet equally profound geographical wonders has further enriched your sense of calm contemplation. The planet, in its infinite complexity, continues to unveil layers of mystery and beauty, inviting us always to look closer, to listen more intently, and to appreciate the intricate dance of its elements. There is no need to retain every detail, only to allow the soothing rhythm of discovery to wash over you, preparing you for a night of restorative rest. We are deeply grateful for your presence on this journey and for allowing us to share these tranquil moments of geographical revelation. If you find solace and wonder in these explorations, consider lending your support through a like or subscription, helping us to continue unveiling the Earth's quiet wisdom. Until our next gathering, may your dreams be filled with the harmonious echoes of our planet's enduring majesty. We eagerly anticipate our next shared moment, when we will delve into yet more of the 100 incredibly interesting geography facts. Sleep peacefully now, knowing that the Earth continues its grand silent work, full of wonders waiting to be discovered.